Okay, great. Hello, everyone, once again, and welcome to today's presentation of the world's largest outdoor inverter, the SG6250HV MV. My name is Paul Rusch. I'm a technology engineer with Sungrow Europe, and I will be moderating today's webinar. This webinar is live, and a recorded version will be available after the presentation. We will send an email with the instructions how to access the video and follow up with any unanswered questions. We love to hear from you. Please use the chat box below to answer your questions, and we will have a Q&A after the presentation. If you are just joining us, welcome. You came just in time, as I'd like to now introduce our presenter, excuse me, Mr. Javier Blanco. He's a European PV technical manager with the Sungrow Spain subsidiary. Javier is really knowledgeable in his field, and I'm honored to present him to you for the next 45 minutes. Go ahead, Javier.
Okay, thank you very much, Paul. Thank you all for attending this webinar within the virtual expo show that we are handling this week. Okay, so I will introduce now the turnkey solution, the new turnkey solution we have developed for the utility PV plant, named SG6250HV MV. Okay, I will start talking about the design drivers of this new solution, which has been, on the one hand, the continuous cost decrease of all the PPAs, motivated by the drop of all the PPA price all over the world. I think in the image it's very clear how is the situation right now. In every new auction, the PPA prices are decreasing substantially. So in the end, all new product release related to this utility PV plant components has to be in accordance with that. Okay, obviously. On the other hand, large utility PV plants are becoming more and more demanding in terms of grid support, requiring very good performance in terms of short circuit ratio, being able to operate in very low SCR conditions, also with very quick response times and very wide requirements of reactive power support and grid support overall. Okay, so basically, those have been the main design drivers for this new solution. Okay, so let's go now through the insights of the new solution. As you can see, it's a containerized plug-and-play solution. Okay, integrated in 40-feet container, reducing shipping cost and installation cost at the very minimum. Okay. Even when the station is containerized, all the components are designed for outdoor environment. Okay, the MV station is composed by an all-in-one solution built up with two SG3125HV-30 central inverters, the new version of central inverters Sungrow is launching this year. Okay, the solution comes up together with a LV transformer plus RMU. Okay, making it 100% plug-and-play solution built in factory, and just DC wiring and MV-AC wiring have to be connected to this station to make it fully operative. Okay, the rated apparent power of this MV station is 6.874 kVA up to 45 degrees. Okay, in the range from 45 degrees to 50 degrees, there is a small rating up to 6250 kVA up to 50 degrees. Okay, so the rating between 45 and 50 degrees is linear between these two values depicted here. It is able to be connected to an AC grid from 20 in the range from 20 to 35 kV. Of course, being able to operate in 50 or 60 Hz. Talking about grid frequency. The maximum efficiency of the central inverters is 99%, with a Euro efficiency of 98.7%. Okay. One of the important features of this MV station is that we can manage a DC-AC ratio up to 1.8. Okay, which is relevant in many countries where this utility solution is being deployed in the future. Okay. There is 24-hour online AC insulation monitoring. Speaking about the grid power, grid support that we introduced at the beginning, we have reactive power response time below 30 milliseconds, and we can operate stably within SCR, source ratios above 1.2. Okay, meaning it can work in very weak grids in countries such as Australia or India, for example, where the wicks can be the grids can be really weak, and the operation has to be stable even within those conditions. Okay, the inverters are already conceived for the future. Okay, we have a built-in ESS interface where we can do a DC coupling even in the moment of the procurement, or even in a next step. The system's already considered the ESS interface. Okay. Another important feature is the wide MPP range. Okay, for this solution, we remain with the 875 1300 volts, which from our understanding is one of the most important topics in this central inverter solution. Okay, to avoid the loss of yield due to poor MPP tracking, especially in those countries where there are reactive power requirements that could even reduce this MPP rate. Okay. We are talking about a highly integrated solution. Okay, as we can see in the picture, well, this could be the layout of the complete PV plant. Okay, considering here PV side, the modules, the combiner boxes, trackers, etc., connected to the inverter, and on the other hand, we can couple in DC side ESS system composed by battery plus DC-DC converters here. But in the end, once everything is connected to the MV station, the connection is directly to the MV grid, and that's it. There's nothing else to be done on the installation. Okay, so it's highly integrated. We have built-in PID solution. Okay, a maximum of 48 inputs. These inputs with 4 MPPTs each inverter. We have 2 central inverters here, as I already mentioned. So we have up to 24 inputs per inverter and 4 MPPTs, okay, meaning 2 MPPTs per inverter. So also this is an important feature. Like we discussed, we have this DC ESS interface that can be used for a DC coupled solution. We also have integrated a smart communication unit. Okay, where we can gather all the communication, all the information of the system, and can be sent to a monitoring device, either local or remote. We will talk about it later. Okay, we have also AC insulation monitoring and auxiliary power for tracker system that can be used directly with our MV station. Okay. Well, one of the main important topics when designing a component for a PV plant is the minimization of LCOE. Okay, I'm going to show now how we contribute to reduce the LCOE in a utility scale PV plant. The first important parameter, of course, is the efficiency of the inverter. We achieve a maximum efficiency of 99%. This has been considered and fully optimized from the beginning with the right circuit design, algorithm concepts, proper selection of components, heat dissipation, everything counts here. And having a maximum efficiency of 99%, even when there can be only small, it can look like small figures. Small figures count here. Okay, so a small increase in efficiency can lead to high revenues in the long lifetime of the whole system here. Okay, so we are talking here 1,800 megawatt hour for 100 megawatt peak estimated versus efficiencies in the market below the 99%. Okay, regarding Capex, basically here we can have a quick comparison of the string versus central inverter. Well, mainly the Capex is still $0.0 lower in central inverter, okay, rather than in string inverter, where the rest of the cost of the PV plant are basically the same, especially in big utility PV plants in flat terrain, okay, where we are promoting this central inverter solution. We can see that in these cases, OPEX is really similar, so the Capex is still playing a difference in the central inverters here. So let's say in 100 megawatt peak PV plant, we can save around $700,000 still with the central inverter. And let's remember, we can work with this kind of solution with a DC-AC ratio up to 1.8. Okay. The block design can achieve up to 6.8 megawatts. This is what we are considering with this MV station. Okay, and it's in the range of the optimized block size for these large utility PV plants. Okay, it can be. It's I think something shared by all the players in the industry that a PV block between 6 and 7 MVA is more suitable in terms of overall cost. Okay, and this kind of block in the range of 6.8 megawatts can also reduce a lot of logistics by reducing the number of MV stations to be shipped to the same PV plant, etc. Okay, so talking about the block size, I think it's in the suitable range in terms of reducing Capex, OPEX, and in the end LCOE too. Okay. Talking about OPEX here, there's a lot of information that can be managed from the inverter. Okay, more than 1,000 parameters and variables that can be monitored and available in the monitoring system of this chunky station, with more than 200 fault type indicators, and that allow the whole system to have a 100% lag prediction in the system, which in the end, of course, makes things in the O&M side easier. Okay, OPEX is also an important part of the LCOE. So everything that leads to a reduction of OPEX cost in the end is good for the investor. Okay. Here we have remote monitoring and also remote firmware upgrade for all the components. Okay, so we could connect remotely through our iSolar cloud monitoring system from either a tablet or a personal computer or even a cell phone. We can connect remotely to the inverters and perform firmware upgrade or get some remote monitoring. On top, of course, of the local monitoring that can be included in the PV plant, we can do some things, actually most of the things remotely too, okay? So here through the fiber switch and the smart communication unit,
what's going on? Yeah, we can't hear you.
we connect directly with the components inside the. Hello? Okay. Okay.
Yes. That's okay.
Well, our result with a large efficiency, we get yield increase. With a low capex, the invest decrease. And by having a good monitoring system, we can save the O&M cost. So in the end, all leads to LCOE decrease, which is the main goal of the selection of the components for these PV plants. Okay. Talking about grid support, the second driver of the design of this new solution. We have on the one hand the fast power response together with Q and night function. Okay. The reactive power response is unique in this inverter and is verified by third party. Okay, we have a response time of reactive power less than 30 milliseconds and inactive power less than 140 milliseconds. In the end, these requirements are really important in the new grid codes, not only in Europe but in many countries all around the globe. Okay, so we also have a Q at night function that can perform as quick as the daytime grid support. Okay, so also something that has been considered specifically for this design is operation in countries with low SCR. Okay, for this there is a patent algorithm that has been validated through hardware in the loop. Okay, so it enables the inverter to work in very low SCR ratios, meaning very weak grids. So it makes this central inverter able to operate almost any grid in the world. Okay, even if the short circuit power is really low, the inverter can't operate stably in there. Okay. Regarding the DC coupling ESS system, we have the possibility to work with that, as we already anticipated. We can manage up to 60% of the nominal power of the inverter, and with bidirectional charge and discharge from the grid. Okay. No important point in all our Sungrow designs is the safety and reliability of the inverter, which is a crucial feature, especially in a central inverter or in any utility PV plant inverter. Reliability is a must. Okay, it's always considered very, very seriously in all Sungrow designs. Okay. Here, one important factor that contributes to big reliability, high reliability in this inverter is the IP65 IP degree ingress protection. That makes the inverter able to work in almost any environment. The corrosion can be also up to C5, so the inverter standalone can be placed everywhere in the world without any risk to low performance due to environmental conditions. Okay, so in terms of safety and reliability, this inverter is very deeply considered from the beginning. Regarding the heat dissipation, this is another key factor also to ensure proper reliability of the system. We have speed control fans for the power module cooling. Okay, this cooling system is contributes a lot to the efficiency. Okay, it makes the power consumption proportional to the rated power of the inverter, so it does not spend more energy if it is not needed. So okay, so it's always in accordance with the power of the inverter. And also for the electronic components, there is a specific heat exchanger. So in the end, the components are not at any time in contact with the outdoor environment. So in the end, it contributes a lot to the reliability of the system. Okay? All these components are crucial. They are placed in a PV plant where the environmental conditions cannot be very suitable for most of the electronic components. So here with this heat exchanger, we can guarantee that the inverters are, the electronics of the inverter are completely independent from the environmental conditions here. Okay. Well, just to summarize, the three main aspects of this turnkey station, we're talking about lowering LCOE as the main goal when designing a new product, a new inverter for utility PV plant. This means increase the yield. This means decrease the invest or the Capex and decrease the O&M. So all these aspects have been considered in this design. Of course, grid support is something mandatory right now in any PV plant in the world. So this is achieved in this new inverter and tested with fast power response, stable operation, and also making it compatible with ESS systems, okay, in DC coupling. And the third leg of the new features of this inverter are the safety and reliability of the new inverters, which is granted by the corrosion degree of enclosure and the IP degree of the inverter, of course, and by the efficient heat dissipation. Okay, so all these are mainly the main aspects of this new design. We are already having some pre-sales of this inverter, so we just wanted to introduce here the main topics. But of course, you can contact us for further detail or further study of your specific application in your PV plants, starting from end of this year. Okay. So basically, I wanted to be quick with the presentation so that we can have time enough to answer your questions. Okay. So now is your turn to ask anything you want to know about this.
Yes, that's correct. Thank you, Javier, for the presentation. We now conduct the Q&A. If you have any questions, type below in the box and we will get to them and forward them to Javier. We do have one question here. Is what is battery voltage?
Well, it has to be compatible with the MPP range of the inverter, of course. So if it's decoupled, so it has to be in the range of MPP of the inverter in 875 and 1300. However, there is typically a DC-DC converter on the side. So usually it's the DC-DC converter who is making the adaptation with the inverter voltage. Okay.
Great. I hope that answers
Anything
your
else?
question, Jose. I think he's responding. What is the PF range?
Well, power factor range is typically between minus 0.8 and 0.8. Okay. When we are working in cost-free control mode, it means when we are giving set points directly to achieve the power factor, it has to be within this range. But it doesn't mean it can achieve higher power factors by working in Q mode. Okay, it means for power below the rated power, let's say between 0% and 90% of the active power, rated active power, we can operate within any power factor by giving set points of Q instead of power factor. Okay, so but at rated power, power factor range is plus and minus 0.8, which is usually valid for almost any grid codes we have found so far. Okay.
Great, thank you, Javier. We have a few people typing questions right now. Let's just wait one more minute here. We have a couple. Actually, we have still a half hour for questions. We were pretty quick today with the presentation.
Yeah.
Go ahead and write your questions down, and we'll get them answered. I have one here, Javier, from Earl. He's asking, what's the maximum DC overbuild?
Okay, I guess you're talking about this AC ratio, correct? So as we show in the presentation, it's 1.8. Okay, is what we are considering here in this design. You can find it on page here, for example.
Great, thank you, Javier. Perfect. Are there any more questions from everybody? Okay, it seems like these are all the questions that we have for now. To conclude, I'd like to thank our presenter and, of course, our audience for joining us today. We do have more webinars this week, including we have one more today. You can register for the webinars at sungrowmarketing.com and join our virtual show here and check out the other webinars at other times. We hope to see everybody later on, and I wish you a great day. Thank you.
Okay, thank you very much. Thank you all. If you have anything else, we still have some minutes. But
we do, yes.
There are some of them typing now.
We do. We will stand by for a couple more minutes if anyone has any questions, right? Okay.
Okay, Christian is asking about if the presentation is going to be shared. It will certainly be same as with the other virtual show webinars that we will be handling within this week. So sure, it will be shared afterwards.
Absolutely. I think we're up with our marketing department, and they'll share the webinars definitely to the attendees per email, and we'll also make it available on our website as well.
Okay.
And Jose, we'll contact you after the webinar. Javier will contact you, and right? Okay.
Sure. Well, the inverter is right now available for pre-sale. We will start doing the first deliveries end of this year, roughly starting end of October, November. Okay, end of October, November, DTP Europe. Okay. About the weight of SG6250 is roughly around 23 tons. Okay, 23 tons. Yeah, Gagan, like we discussed, we will already share to all the attendees this presentation. So yeah, rest assured, we will share it after the.
Absolutely, we are. Exactly. We'll share the video and PowerPoint if necessary. We have all the email addresses from your registration, and we will share this after the presentation. We still have a few more questions coming in. Let's give a couple more minutes.
Well, how many RMU can fit in the enclosure? It's one RMU. We can support different arrangements if required, but in the end, there's a space for the RMU here in this indoor compartment over here. Okay, so these RMU can usually fit up to 3 modules. Okay, typically the 2-line modules plus 1 transformer protection, 2-line capicles and 1 transformer protection capital. Okay. It is manufactured in our HQ in Hefei, China, Alvaro. Okay, it's plug and play, manufactured and tested after production, and then shipped to the final destination of the people. Okay, inverter output voltage is 600 volts. Okay. Like I explained, this means a wide MPP range in the inverter. We prefer to be a bit conservative here because even though we could increase the power of the inverter by increasing the voltage, we prefer to be conservative here because we see that it is needed. Actually, when we go to demanding grid codes where we have to operate with wide power factor range and also with potentially high voltage in inverter terminals, I think it is worth to have a wide range of MPP. To support all these eventualities. Okay, otherwise, if the MPP range is too narrow, when we have to support reactive power, you can lose yield because of that. Okay, so what is the capacity to compensate reactive power in active and capacity? Well, like I mentioned, it's in power factor plus and minus 0.8 at rated power. Okay, at 6.87 MVA. Plus and minus 0.8. Okay, that is a reactive power capability.
Yeah, here's a certification question.
Yes, this product is specifically focused on IEC market. Okay, there will be a dual version. Okay, typically it will be up to 3.6 MVA, roughly. Okay, basically the hardware of the inverter is very similar. Of course, there are some considerations to take in mind for the UL application. Okay. But it will be available for UL market probably at the beginning of next year, something like that. Okay, I don't have the exact timeline because we are focusing on the IEC market, but they will be UL version for sure, up to 3.6 based on the same hardware layout of the inverter. Okay. We can use the solution for fuel save. Not sure what you mean with this, Jose, if you can explain a bit more. Fuel save.
Wait, Jose, can you elaborate on that question a little bit? We'd love to answer that for you.
Well, in a plant with only gensets, we are talking definitely about a PV MV station here, even when it is foreseen for being connected with a battery energy storage system in the future. But we are talking about a grid-connected PV inverter station here. Okay, where other solutions, we have solutions, of course, for all energy storage applications, but this is a MV tank station for PV grid-connected PV plants. Okay. Medium voltage transformer according to IEC 60076. Of course, good question. It is not only in compliance with IEC 60076, but also with eco design for the use in Europe. Okay, so meaning very reduced losses in the LVMV transformer. We are even considering for the next stage of the application of the European standard for eco design of transformers, starting on July 2021. Okay, be aware that we are having that in mind for deliveries after July 2021. Okay, we are using a oil transformer. Okay, oil immersed transformer. It's not hermetically sealed. Okay, it's oil transformer with radiators. Okay, but not with corrugated tank, but with radiators. But still natural cooling and oil immersed transformer. Yeah. Any other question?
Okay, we have a few more questions. Yeah, okay, great. We will wrap up the webinar now in about 1 minute. If you have any final questions, you can write them below. If we don't have time to answer them, we will email you and follow up with all the questions.
Okay, Alvaro is asking if we include oil retention tank for the oil. We can definitely supply the oil retention tank. It's a separate item though. Okay, it's challenging to integrate it in the container enclosure, but we can provide it customized to be located below the container. Okay, we can deliver that. Of course, it's one of the options of the station.
Great, thank you, Alvaro. Oh. Okay, great. Thank you, everybody. Thank you for your questions. Thank you, Javier. Thank you to our team for making this webinar possible.
Okay, thank you all, and let's be in touch. Okay, I hope to see each other in the virtual expo within this week. So and I also hope you can attend also some other webinars that we will be handling this week, showing our new products for this year. Okay. Thank you very much.
Great. Thank you. Thank you, everybody, for joining. See you at the next one. Bye-bye.
Thank you. Bye-bye.